Hello, welcome again. We are solving some conventional questions of fluid mechanics and machinery. The topic is hydraulic turbine. Question number 4 from Engineering Services Conventional 2009 is a 3-jet Pelton wheel turbine is required to generate 10,000 kilowatt under a net head of 400 meters. The blade angle at the outlet is 15 degree and the decrease in relative velocity while passing over the blade is 5%. Determine 1. The diameter of the jet. 2. The force exerted by a jet on bucket Given that overall efficiency of turbine is 80%, coefficient of velocity 0.9 and speed ratio 0.46. Further, if the jet ratio is not to be less than 10, calculate 3. Speed of the wheel for a frequency of 50 hertz per second for the corresponding wheel diameter. So here it is given that the power is 10,000 kilowatt and head is 400 meters and overall efficiency is 0.8. So, and we know that P is equal to rho Q G H into overall efficiency, and Q is discharge. P is 10,000 kilowatt or 10,000 and rho is density, that is 1000. Q is discharge and H is 400 meters and overall efficiency is 0.8. So from this we can calculate Q comes out as 3.1855 meter cube per second. As there are 3 jets, so discharge is given by Q is equal to 3 into A into B, where A is area of each jet. And so D square, so area is pi by 4 D square, so D square comes out as 3.1855 divided by 3 divided by pi by 4 divided by B. And velocity at the inlet is calculated by coefficient of velocity, that is given as CV. So CV into root 2 GH is your velocity of jet. So CV is given as 0.98. So coefficient of velocity is given as 0.98. So and H is given as 400 meters. So D comes out as 86.817 meter per second. Okay. So now we can put here the value of D. So D comes out as 0.1248 meter. So D is diameter is 0.1248 meter, and speed ratio is given as 0.46. Okay, so U by root 2 GH is your 0.46. Okay, so speed ratio means U by root 2 GH, and root 2 GH we know that H is 400 meters, so U can be calculated as root 2 GH into 0.46, it will be 40.97, 40.75 meter per second. Okay, so this is your velocity of a bucket, and this velocity is same as whether it is inlet or whether it is outlet. Okay, so first of all, because for the Pelton wheel, first of all drawing inlet diagram for Pelton wheel. So inlet velocity diagram for Pelton wheel. As Pelton wheel is a tangential flow turbine, so there will be no axial or radial component in the Pelton wheel. So there will be only bulge component. So V1 will be equal to VW1. Okay, and U is velocity of speed of bucket. So this will be your relative velocity. So V1 is in axial direction, sorry, in tangential direction. U is also in tangential direction, and relative velocity will also be in tangential direction at inlet. So V1 is your 86.817 that we calculated, and U is 40.75. This is your V1, this is your U. So VR1 comes out at 46.067 meter per second. As the ratio of relative velocity at the inlet and outlet is given as 95%, or it is given that there is loss of 5% or decrease in relative velocity while passing over the blade is 5%. So VR2 will be your 95% of VR1. So VR2 will be 43.76 meter per second. Okay. So this is your outlet velocity diagram. So this is your VR2, this is V2, this is relative velocity, this is absolute velocity, this is bulge component, this is radial component, and this is your blade velocity. Okay, and this is your blade angle. So this angle is given as blade angle at outlet is given as 50 degree. So from this angle and from this relative velocity we have VR2 cos 15 is equal to U plus VW2. U is your 40.75 and VW2 is unknown, and VR2 is 43.76 cos 15. So VW2 is your 1.522 meter per second. And force on the force on bucket by each jet or by single jet is, because we have to find out the force exerted by a jet, okay, by a single jet. So it will be rho q by 3 VW1 plus VW2. VW1 we have calculated, VW2 we have calculated, and rho is known and q is known. So this will be 93801 Newton, force exerted by a single jet. And as the jet ratio is 10, so d by d, capital D diameter of Pelton turbine and small d diameter of jet. So d will be your diameter of Pelton will be your 10 into small d, and small d is 0.1248. Okay, so d capital D will be your 1248, and speed of will be your pi d n, and n is given as 50 hertz per second. 50 hertz. 50 hertz means it is wrong. It is 50 hertz. Okay, you can see. So it is 50. So this is speed of will be 195.936 meter per second.